Welcome everybody. Hello, my name is Yasin, and I will be leading the Build on Polkadot WeTransfer Educate Series. GM, please say hi in chat. Make sure to say where you're all coming from. Really excited to have a huge crowd and kicking this event today. Ayo, hey. Hi from India, Chile. Wow, amazing. Hope you're having a great day wherever you're based, and I'm excited to kick things off. What we are in for today is kicking off the Build on Polkadot WeTransfer Educate Series. It's not going to be a regular Educate series because, unlike others, it also has a dedicated bounty involved with it. So apart from being able to learn a lot, you will also be able to put your tester skills and hopefully win a prize from a really big pool. Additionally, the bounty that we, as I just shared, is going to be building a file sharing dApp. It's going to be about building a decentralized file sharing dApp on Polkadot with the Apillon platform. You will be able to put your test skills to the test. You will be able to form skills. You will be form teams. You will be able to work on your own, form groups, and we will be here to help you along the way to hopefully build something new, creative, and wow the jury eventually. There's going to be a huge prize pool. As you can see on your screens, the grand prize pool is going to be $10,000, and you will be able to use the technologies of all the other partners in your project. So that will be Polkadot, File Network, Crust, and Kilt as well. To share a bit more about the bounty and what it entails, I'm going to invite to the stage Patrick and Nino from Apillon, who will be able to provide a bit more, a few more details on how you can make the most out of this program and the workshops that are coming. Let me quickly add them to the stage. That's it for Patrick, and give me a sec for Nino.
Hey, do you hear me?
Hey, yes, I can. And adding Nino to the stage as well.
Alrighty. So yeah, thanks everyone for joining. I'm the growth manager at Apillon. I'm also the Polkadot ambassador and also the initiator of the Build on Polkadot initiative. I would just like to say that I'm super stoked about the response that we got on this event. So there are like more than 500 individual registrations on the workshops, which is definitely more than we expected. And at this point, I would just like to make a big shout out to all the participating Polkadot teams. So starting with Crust, Fala Network, and Kill Protocol, and of course to Bill Laboon, who will be presenting today, and is going to do an intro to Polkadot. So just briefly, with this event, we wanted to showcase that building on Polkadot is not as difficult as it might seem on the first glance. And well, we're on a mission to showcase and give you all the tools for all your future journey. And now I'm going to let Nino take over to present a bit about the product vision on what we're trying to achieve here.
Hi everyone, and greetings from my side as well. Like Patrick said, it's very nice to see huge numbers in attendees of this specific series. Without prolonging the workshop from Bill Laboon, I would just like to say that we made sure that the hacking part is very simple from the technical standpoint. And we also made sure that all of the workshops that are following today's one, and of course today's one, will give you all the knowledge you will need. So if you are tinkering something in the web or even in the web 2, if you know how to build basic websites in React or Next or some other popular JavaScript framework, you will be able to build. Definitely regarding that, we would like to say that we're expecting, really cool products, so maybe even driven towards DGen community. We want to see some sort of UI innovation when building this specific product, and we will give you all the knowledge and all the know-how needed to get there. So without further ado, I would say enjoy the workshops and apply for the hacking part, and see you on the last workshop. good luck.
Thank you both. And for everybody else in the crowd, you will be seeing a lot of both Patrick and Nino, who will be coming here, and probably for all of our upcoming workshops and sharing a few more bits. Thank you once again, Patrick and Nino. See you around. Now, continuing on. We have a lot of things to go through, but first of all, going through the essentials. There are a few things that you need to keep in mind. Most of them has already been shared to you through the onboarding emails, as well as in the Discord, but we'll keep on reiterating these, as these are really important pieces of information that you need to keep in mind of. First of which is the hacker pack. I'm going to leave the QR codes for some time on the screen so you can all try and scan and have access to them. But to give you a bit of insights on what each of these is, first of one is the hacker pack. It's the basically one-stop shop of all the information that you will need for the Educate series. It will contain a list of all the recordings. It will contain all the partner documentations and any additional information so that you can build for the bounties and hopefully win some of the prizes. The second QR code is for finding a team form. This is a short form where you will be able to list some of the skills and your previous experience and basically present your profile in a way. Once that submission is done, it's going to be added to the to what the third QR code stands for. It's basically a board of everyone that has filled in the team formation form. So eventually, you will would like to scan the third link and just look through the profiles of everybody else that have already applied for looking for a team. So as of right now, it's mostly empty. We're just launching this, so feel free to head in to the Find the Team form, fill in and add your profile, and ideally people will end up reaching to you, and you might reach out to other people, and by the end of the program you will be able to find like-minded people to build something. So these are the QR codes. Don't worry if you miss any of these. We will keep on showing all of them on the Discord. We'll keep on making announcements of these, and if you have any questions, feel free to reach out to me on Discord or any of our Encode members, and we will be able to help you out. Moving on, we're starting off with just wanted to do a quick overview of the workshops. We have 5 specific workshops which are going to be happening once per week. Dedicated invites have already been sent. If you haven't, please sign up for all of these events and you will receive an invite in your calendars. Today's workshop is going to be Intro to Polkadot by Bill Laboon. We'll then have next week's going to be Introduction to IPFS and Crust Network by Brian Wu. Moving on to Joshua Spoilers and Fat Contract Introduction and Schrodinger's NFT concept. And then Qt Protocol's Introduction to DIDs. The last workshop is going to be held by Nino, who you just saw, and it's going to be Introduction to WeTransfer Backend Architecture. Each of these workshops will, as I said, will be recorded and will be then made available through the Hacker Pack. So even if you missed some of them or missed them completely, you will be able to watch recordings of them. And then, without further ado, it's time to kick things off with the very first workshop by Bill Laboon, who's also in the audience. Let me quickly add him on stage to kick things off.
All right, thanks everyone. I'm really looking forward to discussing Polkadot here. So for those of you who don't know me, my name is Bill Laboon. I'm the Director of Education and Governance Initiatives at Web3 Foundation. I've been working on Polkadot since the end of 2018, so quite a while, well before launch, and still very excited about everything that can be done on it. So today I'm going to give an overview of what all can be done on Polkadot. The focus is really going to be like the basic concepts and how to build, like the basic concepts of it. Although there are obviously a lot of rabbit holes that you can go down. So at the end, hopefully there'll be time for questions, and I'm happy to take some. And I'll also give you a lot of places where you can find more information if this has sort of whet your appetite for building on Polkadot. So let me share my screen. Okay, let's start with what are the problems with legacy blockchains? So you may know Polkadot was actually the idea for it came from Gavin Wood, who was the former CTO of Ethereum Foundation, the developer of Solidity, who wrote the first version of the Ethereum client. And he actually left Ethereum because he saw that like this concept of like these legacy blockchains had a lot of limitations. First, they can't easily communicate with each other. And we see this, right, that there are bridges between blockchains, but often they're hacked. It's a very complicated thing to get to be done correctly and quickly. There are also some other ways to communicate, such as atomic swaps, that are very limited and slow. They can't scale, right? A sort of a traditional blockchain cannot handle a lot of traffic, and we see this whenever there's some popular activity on a blockchain, like runes on Bitcoin right now, for instance, or CryptoKitties, for those of you who are around for that. On Ethereum, anytime there's a lot of activity, you tend to see extremely high fees, clogged networks, etc. Even in non-traditional blockchains, things like Solana, we see this a lot, where the network gets too clogged, transactions fail, etc. Poor security. Right, so things like 51% attacks, reorg attacks, very common, especially when people are trying to develop a new blockchain. We've seen this, quite often in the past, or in forks, in the past, against Ethereum Classic, against Verge, etc. There isn't really a lot of customization. It's difficult to build your own blockchain that does something, but if you want to use an existing blockchain, you're kind of stuck into the decisions that they made, the architectural decisions that this blockchain or that blockchain made. Poor governance. So we see this either we have systems like Bitcoin where there really isn't governance, or one and it's basically ossified. Changes are very, very slow, or decisions are made by one powerful individual or group, right? A development or a foundation. And finally, upgrades are difficult. So we see this again, Bitcoin is very ossified. We see other networks. If you want to upgrade the blockchain, you need to have all of the nodes also upgrade, which is a sort of a bit of a nightmare, right? It's a distributed system, but you need to convince all of these different nodes to upgrade their software and have a soft or hard fork and continue the network from that, which is why you don't see a lot of network upgrades happening, because it's a slow process, right? So it's hard to evolve. So the idea behind Polkadot was we have these challenges in blockchain development, right? How do we solve them? We see these particular problems, so how do we solve them? So the thought behind Polkadot really is, as Gavin Wood said in a speech that actually, the speech that made me want to work on Polkadot, is that we want to make a bet against blockchain maximalism, that there is no one size fits all. There is no one particular network that has the best of all worlds and will be solve everyone's problem. There are networks with UTXOs versus account-based models. There are networks that provide more security versus less. There's some that have smart contracts and some that don't. And there's all different kinds of levers you can pull and different trade-offs you can make. And none of them are going to be perfect unless you develop a blockchain specifically for you. But all of these blockchains should be able to interact and communicate and share security. So this is the basic idea behind Polkadot. So the official definition is Polkadot is a heterogeneous multi-chain protocol that connects and secures blockchains with pooled security and interoperability. But just to give a little bit more focused translation here, Polkadot is not a blockchain. It is a set of blockchains that work together and talk to each other securely. So when you talk about Polkadot, people often talk about the Polkadot blockchain. That doesn't really exist. Polkadot is actually about 51 different blockchains that all can work together and interoperate and communicate. So these various blockchains on Polkadot are custom built and optimized for specific uses. So we have, we actually have a couple of, you'll hear about some of these, as we call them, parachains, parallelized blockchains. You'll hear from representatives from them elsewhere in the series of talks. But this basic idea of having lots of different blockchains that can communicate with each other, that can talk with each other. You can have a smart contract on one, call a smart contract on another, an asset from one move securely to another. The security is shared amongst all of them. This is the basic idea behind Polkadot. So Polkadot connects these networks together. It handles heavy traffic at scale. We actually had a bit of a stress test. So during the ordinals craze at the end of last year, where one chain of the 51 that make up Polkadot right now handled over 7 million transactions in a day, and the fees didn't even go any higher because it didn't go anywhere near the limits of what the network could handle. And again, that's just one chain. You can imagine, this could easily be multiplied by 51. Industry-leading security, so any chain that is developed and connects to Polkadot shares in the security of the relay chain, which has, last I checked, not that long ago, a few days ago, about $2.5 billion worth of economic security in the proof-of-stake protocol that it uses. It allows you to make custom-built blockchains to meet your needs, or you can build on some of the blockchains that already exist out there. So we'll talk about that, like the different trade-offs that you can make, either building on a blockchain that exists or building your own, or maybe something different, something in between. We have a really interesting on-chain governance system that has no first-class citizens, as we say. It's dot-based voting. One dot is one vote. There is no, like Web3 Foundation can only vote in terms of the dot that we have. Any individual user can only vote in terms of the dot that they have, and we have some interesting safeguards to ensure that this can be done safely. But it really is, as far as I know, the most powerful and open and democratic governance system of any blockchain ecosystem out there. And what I think is really interesting from a development standpoint, one of the things that made me interested in Polkadot in the first place is that upgrades are very easy because the code for chains is actually stored on chain. So this means that if you want to upgrade the software, if you want to upgrade a chain, you don't need to coordinate all of the people running nodes. You just put out a new version of the software on the nodes. Any node following the chain can see that code and they self-upgrade, which is, again, really interesting, allows Polkadot to evolve very, very quickly, much faster than any other chain out there. So the Polkadot Network, if you're interested in taking a sort of developer-focused look at it, we have a tool called polkadot.js.org, Polkadot.js app. This is, again, not a real user-facing interface. It is a bit complicated, but it's extremely powerful. And if you build a blockchain, you can connect with the Polkadot SDK. You automatically have this can automatically connect to it. So you automatically have a nice user interface. Again, developer focused, but you have a web-based interface almost immediately whenever you create a new chain. You just connect to the URL and you have an interface. So this makes development pretty nice, right? If you're developing a blockchain, you automatically have a nice web-based UI that can go along with it as soon as you start. We have lots of nodes running. We have a telemetry system, so you can check this out. You can see in this screenshot's actually a little bit old, but you can see we have 2,109 nodes that have elected to connect to telemetry. You can run a node without connecting to the site, but we also have, as you'll notice here, a few other networks that also are built on the Polkadot SDK. Not all of these are in Polkadot, so you can use Polkadot SDK to build a chain, And then if you want to make, for instance, a proof of work chain, instead of using a proof of stake or connecting to Polkadot itself, you can do that. Or if you have other things that you would like to do, you can use the Polkadot SDK. It's a very powerful SDK for developing blockchains, and not just for Polkadot. So let's talk about why you would want to do this, right? Why would you want to build your own blockchain and connect to Polkadot as opposed to just writing up a smart contract? So the idea is, right, that you have a couple of different levers that you can adjust, right? So single blockchains can be built to do one thing very well. So, I have here Bitcoin as an example, transferring assets. Monero is very good with privacy, or Zcash, the idea of private or non-private. But none of these chains that I'm mentioning have smart contracts, right? They're focused on one thing, asset transfer, privacy, etc. You also can build one chain that does a lot of things okay, right? So Ethereum, for instance, or Solana. The idea for any of these is not that, all right, we're focused on one specific thing, but rather you can do anything. But it might not be perfectly suited for what you're trying to do. So the idea here is, if you are interested in building a chain, right, then you can connect in to the Polkadot network. You develop your chain using the Polkadot SDK, and it can connect in to what we call the Polkadot relay chain. So this is sort of the central chain of Polkadot. So when people talk about the Polkadot blockchain, what they usually mean is the relay chain. We consider the relay chain a layer 0. So this is different than a layer 1 like Ethereum, where you have layer 2s executing on top of it. Because the idea of the layer 0 of the relay chain is that it should do nothing except secure the parachains, the blockchains that are running on top of it. The idea, there is some other things that the relay chain does right now, but we always joke that the goal is to have the relay chain get down to 0 transactions per second, that you shouldn't do anything on the relay chain. Anything that is done on the relay chain now, besides securing these parachains, should be something that's moved to a parachain. So there are a few things that are still done on the relay chain, such as staking and governance and dot storage. All of these are planned to be moved to parachains. So the relay chain will then just secure these other chains. So that's why we call it a layer 0 as opposed to a layer 1. Ethereum, for instance, it secures its layer 2s, but you also can run a smart contract directly on Ethereum. You cannot run a smart contract on the relay chain. But again, this is by design. If you want to develop a smart contract, there are lots of different parachains that support smart contracts, and these can interact with each other, from one chain to another. So a smart contract on parachain A or an asset on parachain A can call a smart contract on parachain B, or that asset from parachain A can go over to parachain B. I want to be clear, though, that this interaction is not a bridge, right? So everything in Polkadot, all of these different chains are actually operating under the same consensus. So this means it's not a bridge where you have, all right, consensus A like Ethereum and consensus B like Bitcoin or Tron or Binance Smart Chain or whatever, but rather all of these chains are actually acting as shards of Polkadot. Right? So they are their own chain, but the relay chain secures all of them. The relay chain is sort of the final arbiter of truth of what's happening. So this allows us to interact from chain to chain extremely securely, because there's really just one chain that is controlling all of this. It's one consensus mechanism. It's like sending ETH from one smart contract to another in Ethereum. It's all in the same consensus, which means that it's much more secure. So just briefly to go over the architecture here. So we have a relay chain and we have validators on the relay chain that are producing blocks. We also have collators on the parachain. So these are nodes on the parachain that we don't have to worry so much about the trust assumptions, actually, as long as there's one honest collator on a parachain, then you're good to go for that parachain. For the validators on the relay chain, it's a bit more complicated. But those we do have, again, I'm happy to send some information about how this is done and how they're trustworthy and what the trust assumptions are. However, so we have a large number of validators producing blocks and validating what is happening on these relay chains. It gets that data from the collators. Right now, parachains can connect for a long period of time, or we can have different parachains connect for just a block at a time. To be more efficient, you may have heard, if you've been around Polkadot for a while, you may have heard the term parathreads. The term we prefer now is on-demand parachains. So if you have a parachain that doesn't need to produce blocks as often as the relay chain, so right now that's 6 seconds per block, then you actually could have a much cheaper time by just connecting on a per block basis, maybe once per day or once per hour, once per Bitcoin block, anything like that. So we provide, again, a lot of variety, a lot of possibilities of how you can build on Polkadot. So this is something you're going to see, come up over and over again. Polkadot was sort of made by engineers for engineers, and what engineers want often is, they want to build exactly what they want to build. So we provided a lot of leeway, a lot of different variables that you can tweak for your parachain, depending on what your needs are. So, pardon me, I'm just going to have a drink here before I continue. So I mentioned earlier that Polkadot nodes do not all need to be upgraded when there's a runtime upgrade. And the reason for this is that all of these nodes, these parachains, the relay chain, any Polkadot SDK built chain actually stores the code for the chain on the chain. So it's actually a blob of WebAssembly bytecode. So this bytecode is stored on chain. It's modifiable by the system itself. So what this means is that any change can be made by the chain. So if you want to change, for instance, a governance parameter, or a staking parameter, like what is the ideal staking rate? How many validators should we allow at a maximum? This is something that can be tweaked on chain, often by governance. Although if you want to not have governance on your system, if you want to have a super user that can do everything, you also can build that. All the way to the entire code of the system, what the rules of the system are. So this makes it really easy to add updates, to make changes, if the network agrees. You generally do not have to, send a message out, over Twitter and over Element and Telegram or Discord, whatever, saying, hey, everyone needs to upgrade starting at this block. It's just, hey, if you're following the chain, you automatically will change the parameter or the code or whatever. So a way of thinking about this, I'm an old school programmer. I was a Java developer for a long time. If you're familiar with JVM, like you have the Java virtual machine, like this virtual machine that runs your Java code, your Java bytecode. It's not your computer. It's like a virtual computer inside. You can think of this as like this JVM as acting sort of, this is the way Polkadot works, right? You have the Polkadot host that accepts a runtime. That's a WebAssembly blob. Just like the JVM accepts a blob of JVM bytecode, or any virtual machine takes like some code and runs it. So again, this is I feel like you can tell Polkadot was developed by software engineers, because we saw what are the problems? What have people solved in terms of traditional software engineering that we can take and use in the blockchain world? So in a traditional blockchain, what you would see is essentially a fork. Whenever you change the rules, you need to ensure that everybody is following the rules, right? So, and if you don't, if your node doesn't, it's going to follow the old chain. So either it's going to see different blocks, it's going to see some different chain, or it simply won't see any blocks. It'll look like the network is stalled. But with Polkadot, as long as you are running a Polkadot node, if an upgrade occurs, your node sees the new rules and automatically follows them. So again, this is one of those things that it may not seem like a huge change, but when you look at other networks, look at Bitcoin and how often it has soft forks. It's very rare, once every couple of years. Even like Monero or Ethereum that have hard forks pretty often. These are not common, right? They occur occasionally, every year, 9 months, 2 years, etc. Whereas with Polkadot, since it launched in 2020, it's had over 50 runtime upgrades. So several per year. Whoops. Sorry, I had a copy of the. So what this means is, you as a developer, you can continue developing and making changes and upgrading, and it's very easy for the chain to follow it. So because of this, the other thing that's nice for you as a developer, you just, you take your chain, you write the rules for it, you write those in code, right? You compile it, using the Polkadot SDK, you develop a runtime, you generally using Rust, although you could use other languages. There are some teams working on that. You write the code for your blockchain. You don't have to worry about like networking code or the security behind it. Security in terms of like the security of the network, right? Doesn't mean you don't allow anyone to access any account or anything like that. And then you can just plug in to our system. You can focus just on making this runtime, making the rule changes. You don't have to worry about writing database code or anything like that. It's all part of the Polkadot SDK. Just focus on the rules of your blockchain and code that up. So how are these changes made? Right? Whenever you want to make a change, we can't just say, well, Bill wants to make a change, so all right, yeah, I'll follow Bill's rules. Although theoretically, you could write a chain, right? I've always considered making a Bill chain that would just be like, all right, the rules are Bill can do whatever he wants, just for fun. You could do that, right? It is theoretically possible. However, on the relay chain, on the main chain of Polkadot, and for most chains, we want to have some form of governance, right? We want to allow the holders of the token to make decisions. So there are several ways to do this. We actually in Polkadot used to have something we now call Gov1, or just democracy, you may hear it referred to, that had some first-class citizens. There was like a technical committee that could do things. There was a council that got voted in. But now we have OpenGov, which is our next generation of decentralized governance. It's been live on Polkadot for about a year now, and on Kusama, our Canary network, for about a year and a half. Excuse me. So the idea behind here is that we have different tracks, and anyone can vote on them. One dot, one vote. You can have lots of different referenda, as we call them, decisions, proposals to be made happening at the same time. And they have different tracks. So these tracks are basically different kinds of proposals that can be made that allow you to do different things and have different security mechanisms in place. So for instance, if I wanted to give a small tip to somebody from the Polkadot Treasury, the Polkadot Treasury is actually pretty big. It has about $381 million worth of DOT in it right now, as well as a few other assets. And I can give a small tip. Somebody has done something very cool. They've built something. I can make a proposal to tip them. And I would put this on the small tipper track, which allows you to make a treasury proposal only up to 50 DOT, for instance. That is very easy to pass. You can see here the small tipper. It can be passed very quickly. You don't need a lot of support for it or approval. We'll talk about what those mean in a second. But it's essentially very easy to do a tip. Now let's say I want to actually change the code, right? I have a new feature I want to add. I need to change the code of the chain. I'm going to add some awesome new feature. That would have to happen on a root track. This is going to be much more difficult to pass things on. You need a higher percentage of approval. You need a higher percentage of dot voting for it in order to get it to pass. So there are 13 different tracks. Small tipper is the easiest thing to get something passed on. Root is the hardest. But there are lots of other tracks that allow you to modify aspects of the system, and they're easier or harder to pass things on. So essentially, what you need is two of two things. You need an approval percentage. You need a percentage of the dot voting for it to be in favor, but you also need support, which means actual percentage of all dot in existence. Because you can imagine if I wait until Christmas, for instance, or Easter when nobody's looking at Polkadot governance, and I vote and I'm the only one that's voting, and then if it's 100%, for give Bill $1 million dot from the treasury, that's certainly not a good thing. So we actually have to wait for a certain amount of support for this to occur for me before I can give the dot. And both of these curves go down over time. So the support level needed gets less and less as time goes on, and the approval curve gets less and less as time goes on. So if I want something, for instance, to pass very quickly, maybe in this example, I might, like within the first week, generally there's 28 days in total for voting, I might need 25% of all dot voting for it, and at least 75% to say aye, yes, I want this. Whereas if I wait, if I do this and after 3 weeks, well, as long as 1% of dot have voted and 53% are in favor, then it can pass. Generally, both of these curves tend towards a 50% approval rating and a very small level of support, but some percentage needs to vote for it. So OpenGov has we could talk about that for hours, but I do think it's a very interesting way of ensuring that everything is done democratically. Hybrid consensus. So this is something that I feel like isn't really spoken about too much about Polkadot, but I think it adds a lot of really a huge amount of benefit because it gives you sort of the best of both worlds. So when you talk about finality, that is, a block being like definite, all right, this is, we all agree canonically, this is the block. There's two main ways to do this. There's probabilistic finality that Bitcoin has, for instance, where you're never 100% sure that you were on the right canonical chain in Bitcoin. This is why they say, wait for 6 different confirmations of blocks before you assume that a transaction is final. So this is probabilistic. It's a percentage game. And there are other mechanisms like Tendermint, which Cosmos uses, that have provable finality. You can verify that, yes, this is the canonical chain. But there's problems with both of these, right? With probabilistic finality, you're never 100% sure you're on the right chain. It takes a while. With provable finality, you're vulnerable to stalling. So that's another problem, right? You don't want to stall. So Polkadot sort of gives you the best of both worlds. We have probabilistic block production using something called BABE, blind assignment for blockchain extension. Excuse me. That is going to always produce blocks. You always have liveness. And we have a separate finalization gadget. So this is similar now to what Ethereum has done. That's sort of going behind the chain. So generally what you see is a block is produced and anywhere from, this says 20 to 30 seconds. I would say generally the lower end of that, maybe like 18 to 24 seconds, almost always. When there is a problem, like a network partitions, a bunch of validators go offline, we actually can continue with probabilistic finality. And then once we get enough validators back online for this full finality, it actually can catch up very quickly. Within the span of a block, it can do thousands or hundreds of thousands of catch up with hundreds of thousands of blocks. It's actually pretty amazing to see. So you do have like the best of both worlds here, right? Worst case scenario, you sort of fall back to Bitcoin style block production, but generally you get the benefit of having of provable finality. Like in 99.9% of the time, you have this nice provable finality. But in the rare instances where there's a major network problem, you are still live, right? So I'm not saying this, if you're familiar with the CAP theorem, this is not saying that we've totally solved CAP, where you have consistency, availability, and partition tolerance. But we do have essentially consistency and availability and partition tolerance, just in two different mechanisms. So again, this is done with two mechanisms, Babe, which produces the blocks, and Grandpa is the name of our finalizer. So you'll always know either you're on a non-finalized block that's been produced, or like it has been finalized. This is definitely like the canonical chain. All right, so I want to now, that's Polkadot sort of from an architectural perspective. All of you are builders, so I want to talk a little bit about building. We generally use Substrate, the Polkadot SDK, for building blockchains. And the cool thing, I think, about Substrate is it took the ideas, again, of traditional software engineering and applied them to blockchains. So anyone here that has developed something, you probably have not developed it entirely from scratch. You've used some libraries, right, or gems or eggs or whatever you call them in your whatever language of choice. So the idea with Polkadot SDK is you should be able to take these libraries and add features to your blockchain that you want. So this uses something called Frame, the framework for runtime aggregation of modularized entities. So it's a bunch of modules that you can take and just plug into your blockchain very easily. There are hundreds of these modules out there. We call them palettes to go with the like the art theme. Like Frame has palettes that you can add, right? So you select them. So you want Babe and you want Grandpa for your chain. You want to add multi-sigs. You want to have atomic swaps. You want to have an identity module. You want to run an EVM, an Ethereum virtual machine in your blockchain. You just add these particular things to your runtime, and very easily you have these additional features. So this allows you to mix and match at a very high level. If you want to add particular features to a blockchain, it's very simple, because there are lots of these libraries out there and you can add them. Or if you want to modify them, you also can. So if we look at a Substrate node, what it actually looks like, we have the consensus mechanism around it. We have WebAssembly, and then we have your particular runtime. Right? So again, if you think about this runtime, this is your code that you built and is going to run on your blockchain, but you can use the same kind of host software that all these other parachains are running. If you're interested in building a chain, we have something called the Substrate node template. This is just a basic blockchain that you can build. Again, as a former software developer myself, it was always easiest to have start with something working and then modify it, as opposed to create something from scratch. So you can download the Substrate node template, just do a git clone. You automatically have your one computer, your one user blockchain. You then can either add some new modules or modify the ones that exist, play around with it, etc. Then you have your own running blockchain. So what this means for developers, unlike other chains in other ecosystems where you have to make a smart contract, you can't develop your own chain. Polkadot really gives you the whole gamut of technical freedom. So at one end, you can just use an existing dApp, right? I want to participate in the participation market. I'm not going to make it myself. I just go to Zeitgeist. If I want to swap, I go to HydraDX, right? If I want to store something, I can use Crust, right? There's all kinds of different chains out there that already exist, and I don't need to develop anything to use them. So that's a lot of development ease. I don't do any development, but not a lot of technical freedom. So we then go, if I want to build a smart contract, that's a little bit easier. It's a little bit more difficult, rather, but I have a lot more freedom. I can take the Substrate node and use that. I have a little bit more freedom. I can modify my own. I can modify and make my own palettes, right? So I have more technical freedom. I have more power. But again, it's getting harder. Substrate core, I can actually modify aspects of Substrate itself instead of just changing these palettes around. This gives me more freedom, but it's, again, more difficult. All the way to, hey, I'm just going to start with a blank text file and develop a blockchain from scratch. That's perfect freedom, but extremely hard technically. But the nice thing is, well, aside from developing a blockchain entirely from scratch, Polkadot allows you that whole gamut, anywhere from using an app to building a smart contract to modifying the code of Substrate core itself. You can do. It depends on your particular needs as a developer. And while Polkadot SDK Substrate is mostly used for developing Polkadot, there are lots of different teams that have built using the Polkadot SDK that are not part of Polkadot. You have that power. You have the power and the ability to join Polkadot and leave it, or develop a chain and then add it to the Polkadot ecosystem and get all the benefits of security and interoperability, et cetera. Or you can work on your own. So, if you look, there are lots of different chains out there. Avail Network, which is a DA system, is built in Substrate. Cardano Midnight sidechain built with Substrate. BitTensor, an AI chain built with Substrate. Kalupu is a proof of work chain that's built with Substrate. There's I don't know the exact numbers because anyone is free. It's all open source. They can grab this and start running a chain. There may be a few I don't know about, but there are a lot of different well-known chains that are actually using Polkadot technology under the hood. So just to give a bit of a comparative overview, if you're familiar with some other, building on some other ecosystems, I'm not going to go too much into depth on this. I'm happy to share the slides here for everyone, or you can just pause, take a screenshot or something of this. But there are a lot of benefits and drawbacks to building on these chains. I tried to be as fair as possible here, but I'm not an expert. So if someone does see a different, on all these, I'm not an expert on all of these chains, but I have looked into them. So if you want to build on Ethereum, you're essentially restricted, right, to having a public chain using EVM bytecode, which generally means Solidity, perhaps Viper, triple L, I guess, is used occasionally, LLL. I don't know about any other languages, but it's pretty rare to see non-Solidity contracts on Ethereum. Hyperledger Besu, if you're looking for a public permissioned or private chain, but it's still very similar to EVM. Hyperledger Fabric allows you to have chain code similar to smart contracts. You can do a little bit more. Corda, it's very difficult to make a public blockchain with Corda, but you do get the benefit or maybe drawback of using like Java and the JVM. Cosmos with SDK. I'd say the big drawback with the Cosmos SDK would be that its lack of forkless upgrades. Right, you still have to do. You still have to have forks to upgrade. You write in Go, which can be interesting if you're interested in Go. Polygon gives you a little bit more power. You can do EVM bytecode, or you can have your own permissioned or public chain. Substrate, I already mentioned all the interesting things about that. There are a couple of other differences. I think a big one is governance, the shared security of connecting to Polkadot, and the increased interoperability, right? Because you are essentially creating a shard in a larger heterogeneously sharded mechanism. So one thing I want to mention is that this is not just some white paper that someone produced with these amazing ideas that in 2030 will finally be done. Polkadot has been out for a long time. After 5 years of development, in 2021, Parachains were launched. So at the end of 2021, which means that it's been over 3 years, 3.5 years or so that Parachains have been running successfully. There are over 50 of them at the moment, and lots of things are being built on it. Besides from lots of infrastructure and tooling, We have chains like Robonomics, Nodal that do IoT and interaction with the real world. We have lots of DeFi chains like HydraDX and Akala. We have smart contract chains like A-Star and Moonbeam. We have social networking chains like Subsocial, which has several social networks built on it. So there are lots of different chains, so several NFT chains that are built that have all different kinds of capabilities and yet can interact with each other and are all secured together by Polkadot. So very briefly, I just want to talk about XCM, which is how these chains communicate, how they share. This is a generic and extensible language, right? It's a Turing complete language for protocol for interacting between these chains. You can do some very complicated things. Essentially, what this allows you to do right now is, Parachain A, secured by the relay chain, can tell Parachain B to do something, and it's ensured that this is telling it to do something that is valid, right? Like I'm sending, I can't say, well, hey, Parachain B, go send 5 million DOT from someone else's account into mine, right? There actually is, this XCM executor that makes sure what it's doing is valid. And since this is all in the same consensus mechanism, we can ensure that there is no like these bridge issues where something that's valid on chain A is not valid on chain B. This is also live. A lot of parachains support XCM, and we actually see, these numbers are actually a bit out of date. We're now seeing several thousand XCM messages per day. So, a lot of interaction. Again, this could be something as simple as an asset from one parachain going to another, all the way to, smart contract A calls smart contract B on a different chain. So, Polkadot. We got high throughput, so we added heterogeneous sharding. We needed a network that had agency itself, so we have explicit on-chain governance with no first-class citizens. Secure and efficient consensus, we use nominated proof of stake, so no wasteful proof of work. We want a low cost of building, want to make it easier to build, so we have this blockchain SDK, Substrate. It's highly composable because we have cross-chain messaging, so you can have interactions between chains. We allow customizability through runtime development, and we actually have our own on-chain treasury that is automatically, takes a percentage of the staking rewards and then can be spent. We actually have the Polkadot Technical Fellowship, the main developers of Polkadot, and they are paid automatically on-chain. I think this is actually super cool that on-chain treasury swaps automatically, through a governance initiative. This is an ongoing thing once a month. It swaps DOT for USDT and then pays the developers itself. So it really is like a self-rolling wheel. Web3 Foundation, we are sort of the shepherds, I like to think, of Polkadot. We help ensure that things are running smoothly, but we don't own it, right? We're just one other entity in the ecosystem. Parity were the initial developers, but although there are still a lot of developers at Parity that work on Polkadot, we've been moving this the power to the Polkadot Technical Fellowship, which has lots of people from around the ecosystem, from different backgrounds building. As of today, Parachains.info, which is a nice site, shows 203 different projects. Not all of these are Parachains. Some of them are other projects that run on Polkadot or have not yet onboarded. And if you are interested, we have lots of technical and financial assistance, and I'll put some of the links in here into the chat as soon as I'm done talking. We have an on-chain treasury, as I mentioned, that has both treasury proposals. You can say, hey, give me X amount of DOT or USDT or USDC, and I'll build X. We have bounties where people are looking for something. They can propose it, and someone can say, well, I will build that. We have lots of treasury proposals and lots of bounties occurring all the time. Web3 Foundation has a grants program if you are interested in building something that is generally useful to the ecosystem. We also have decentralized futures that is $20 million US and 5 million DOT that we are giving out until the end of June for teams looking to build self-sufficient projects on Polkadot. We have the Polkadot Alpha program for builders. This is technical assistance and a community of builders that are building on the Polkadot SDK. We have the Polkadot Blockchain Academy, which is held 3 times a year in a different country every time. It's been held in England, in the US, I think the next one is in Singapore coming up soon, which is 4 weeks of intensive blockchain training. There will also be an online version of that for this next cohort starting at the end of May. Web3 Foundation has made several courses on edX on things like blockchain fundamentals, building in Rust, building on Polkadot, etc. So lots of different assistance out there. And if you're interested in staying updated, Polkadot.network is our main page. We also have a subreddit. We have at Polkadot on Twitter, Substrate.io. It will help you build on Substrate, get some tutorials. And the Polkadot Wiki is our source of truth for the Polkadot ecosystem, where we have all kinds of information about Polkadot. If you printed it out, it would be something like 400 and some pages, and it's updated all the time. We've had thousands of PRs. So definitely check out Polkadot Wiki if you have any questions about building on Polkadot. Wow, so that was a lot. I see that we have a few questions. Yes, and I don't know if you want to say
yes, there's quite a lot. If I don't, you can check out the question section and you can scroll through it and see the questions one by one that were asked.
All right. Yeah. Oh, great. So yeah, I'll just answer these. So will PBA be hosted in Africa anytime soon? I don't know. Yeah. So I know visas are often difficult. I can tell you we've been talking with several different countries in Africa. To potentially host it, you're rather representatives, not the countries themselves. So we do know about this. And I know visas have been a hard issue in the past, and we're working on that. How does USDC enter the Asset Hub? Yeah, so very quickly, USDC is actually a native asset on the Asset Hub. So Circle produces the USDC. We have several companies that can, I'm not sure the process exactly, but they can make USDC by, I guess, giving dollars to Circle, and it's then produced. Oh, I see Substrate and Go, the programming languages in development. So there is a version called Gossamer built by ChainSafe. That is not yet completed, but this is basically a version of the Polkadot host built in Go. I don't have if you do a search for ChainSafe Gossamer, you might see the latest information. We have another one built with C++ called Kagume, built by a company called Quadrivium, that is live on Kusama, our Canary network, but not yet live on Polkadot. What are the mindset changes as a Java developer to become a successful Substrate developer? Ooh, very good question. So I would say, it depends on what kind of Java developer you were. Understanding distributed systems is very important. And understanding Rust is probably the big change. But I would say if you were a traditional Java software developer, moving to Rust development with Substrate is probably more straightforward than being a smart contract developer. There are some things you need to keep in mind, but if you have a background in distributed systems, I would say that's more important than anything else, is understanding distributed systems and then getting up to speed on Rust. I'd say those are the two big things. How can I implement proof of stake using the Babe and Grandpa, and how to know which supporting palettes I'll need to implement POS? So you'll need to include the Babe and Grandpa palettes. What I would say probably you should do is look at the relay chain and see how they have added those two palettes. So under github.com/polkadot-fellows, there's a runtimes repo. And then you can look and see how they did it. That might be the easiest way. There may be a tutorial on that. I'm not sure. If so, it's on substrate.io. If not, ping me. That seems like something we'd be interested in building. Is the presentation going to be available for download? I don't know. I'm happy to provide it, though.
Yeah, if you can provide it to us, we will make sure to add it to the Hacker Pack, which, as I said, is going to be the one place you can find all the resources for this program. So yes, I will coordinate with Bill after the workshop, and we'll make sure to make the slides available for everyone.
Okay, so if the transactions are not stored in Polkadot, where do they live? So there are some transactions stored as part of the Polkadot relay chain. These are things that happen right now on the relay chain, like staking, like governance, etc. The idea, there are also transactions that live on these separate blockchains, right? And the only thing stored on the relay chain is essentially proof that these other transactions are valid, right? So where do they live? They live on the parachains. So each of these parachains is its own blockchain, and that's where those other transactions will be. And that's where we want all transactions to be. That's a much more scalable way of doing this because we can handle hundreds of parachains. And so instead of keeping everything on one chain, they're essentially distributed amongst other chains. It's just that the relay chain stores the proof that these other chains are valid. How does governance look on other chains? That's a really good question. It's various. So you see some chains. I don't have numbers off the top of my head, and again, there's over 50 chains, so I'm not familiar with all of them. Some of them have the traditional what we call Gov1. So this allows you to do referenda, to propose things, but with a technical committee and a voted-in council. Some of them only have a technical committee. Some of them only have a council. Some have both. But we have some that still have super user, what we call sudo palette, that allows some subset of accounts to have extra power. We have some some parachains that basically have a copy of OpenGov or their own version of OpenGov. It really depends upon the parachain because it's up to the parachain, right? If I'm running Bill chain, which is just supposed to handle stuff for me, then I can have Bill be the super user. I can do anything. If I want to have a very open and democratic chain, then I can use an equivalent of OpenGov. Okay, a quick question about the ways Polkadot can do decentralized storage and how we can do encrypted storage. So I am actually going to hold off on that question because Crust is going to be giving a talk, and I think the representatives from there can give a very in-depth answer to how it works. We actually see, with ordinals, there is actually a way to make Polkadot ordinals, Polkadot inscriptions on chain. This is obviously a very inefficient way to do it, but there are ways already that you can do it in a very inefficient way, and there are ways you can do it much more efficiently, like Crust, for instance. Just a little teaser for an upcoming talk. Any update on Polkadot 2.0? So this is Polkadot 2.0. I just want to be clear, is a term that the community has sort of put around a variety of changes. So these changes are things like asynchronous backing, which allow 6-second block times, agile core time, elastic core time, a lot of different technical changes that allow increased throughput and more efficiency in using blockchains. Using Polkadot and the parachains. So in terms of updates, so asynchronous backing is already live on Kusama. So this quadrupled the number of transactions per block and halved the block time from 12 seconds on parachains to 6 seconds. So again, this is live on Kusama, which is our canary network. That can go live at any point on Polkadot with a governance proposal. All the code is there. It just needs a governance proposal to initiate it. Agile core time has gone live. So Agile core time allows these on-demand parachains or buying bulk leases of core time. So this again is already live on Kusama, and core time sales, being able to buy them instead of just buying them on a per block basis, goes live in about 5 or 6 days, early next week. I don't have the exact date. These other things that are coming, like being able to use multiple cores at the same time, over the next few months. So again, Polkadot 2.0 is kind of a very slippery definition because it's a lot of different features, but those features are already being tried out on Kusama, and it should be coming to Polkadot soon. You said the Polkadot blockchain will have one online. I think I'll share a link. Actually, I'll share a bunch of links that maybe I'll put in the chat right now. But if you look at the one on Blockchain Academy. There's information there, as well as I'll include the link to the Blockchain Academy book. So if you just prefer, instead of attending, just reading everything that they offer, then you can take a look there. But that should have information on the online version, which is coming at the end of May. What are some basic ways to experiment with XCM without setting up a parachain, maybe from the node template? So you actually could set up 2 substrate-based chains with XCM. Probably an easier thing to do might be to go to West End, which is a testnet, or Rococo, which is another testnet. You can try out XCM on there if you're looking to just see how it works. Or Kusama. Kusama is a economic value-bearing chain, but it tends to be very, very cheap. Our motto for Kusama was expect chaos. So it's very cheap. It allows you to do things and try stuff out. So you don't have to set up any parachain. You can just go, call the extrinsic and put in the XCM and see what happens. Do it on a testnet. Who cares? It's a testnet. Like Rococo. Or if you want to, if you're feeling a little dangerous and you want to test in prod, you can try it on Kusama pretty cheaply. Oh, so I think, very, very quick answers to a lot of these questions, but I think I answered all of them and provided a lot of links if you want to dive a little bit more deeper.
Thank you, Bill. For everybody else watching, all of the sessions will be recorded. So if you did not probably hear an answer to some of the questions or missed some of the links, we will try to provide. You will be able to watch the recording. As I said, recording will be in the Hacker Pack. The links and the presentation itself will be made available as soon as possible. I hope so the next hour or so. And if you have any questions, please do sound off in the Discord, and we'll make sure to forward your questions to the relevant people and give you the answers. Just a quick reminder about next week's session. As already hinted, it is going to be on Introduction to IPFS, and it will be hosted by Crust. I don't know. My screen share should be working now, and it's going to happen on the 2nd of May. Invite should be in your calendar, and if you have any questions, do sound off, as I said, in the comments or in Discord, and we'll make sure to follow up. Any last words, Bill, to round things off?
No, just thank you for having me. I hope I've excited you all a little bit about Polkadot. Like I said, I think it's a super interesting approach to blockchain, and really gives a lot of room to build on. So I hope I've inspired you to build something.
You most definitely have. This was an amazing presentation. As you can see, people are really eager to dive into the slides and have them available. Thank you once again for being here. Thank you also again to Patrick and Nino, who joined at the very beginning. Thank you all for joining here for this session, and see you all next week. And as I said, in the meantime, we're all super active. Feel free to DM us, ask any questions, and we'll be around to help. Have a great day, everyone. See you all.